Chapter 20 is about electrochemistry. And the quote here seems a little strange out of context. "One day, sir, you may tax it." Quote from Michael Faraday. Michael Faraday was one of the scientists who basically discovered electricity, was studying electrons and what they could do, etc. And Mr. Gladstone, who was in charge of all the financial stuff in England, was asking him, well, what's the practical worth of this study? Why is this worth funding, basically? And Faraday responded, "One day, sir, you may tax it." As we know now, electricity was absolutely worth any money invested in discovering it and figuring out how to use it, right? And so this is a great example of the importance of basic science research, where we are just figuring out nature. We're learning more about nature, not necessarily with any practical purpose in mind, but just exploring nature, learning how things work. Because when we learn how things work, then we find things that we can use to our benefit. I think we would all agree that electricity is a good thing. So, lightning and batteries are related to each other. Lightning is a very dramatic demonstration of a flow of electrical charge, and it also demonstrates the power of it. A battery works on similar principles. The driving force for both of these is the same. Electrons flow away from negative charge and towards positive charge. This section of the book has a nice little explanation of what lightning is and how it works. Basically, in the clouds, we get a separation of positive and negative charge, and that builds up until a path between those two areas can be formed, and then it resolves that difference in charge very dramatically. Here we go. See? I read the chapter, I did not look at my slides. Okay, so in a thundercloud, you get violent air currents, and water droplets are running into, colliding with ice particles, and so electrons get knocked off of molecules, and you get positive charges and negative charges. The positive charges accumulate on the ice crystals, those move to the top of the cloud, and the negative charges remain in the wet, slushy bottom of the cloud. So you get this charge separation. Eventually, a channel of ionized air will develop, and that allows massive amounts of charge to flow through it, and this is lightning. Mostly this occurs within a thundercloud or between two different thunderclouds, but if the cloud is close enough to the ground, that negative charge at the bottom of the cloud can create a positive charge in the ground, and you can have the lightning flowing from the cloud to the ground. And that can be very dangerous. It can kill you, it can cause fires, shatter trees, etc. Any questions about lightning? So in a battery, we have two different substances that have different affinities for electrons. One of the substances likes electrons more than the other does. And when these substances get separated, one will develop a positive charge and the other develops a negative charge, just like the cloud. The charge separation will exist until there's a way for the electrons to flow from the negative end to the positive end. Well, we can create a channel here, a conductive path, using a metal wire. That allows electrons to flow through the wire, and we can get them to do work as they flow through the wire from the negative end to the positive end of the battery.